and substitute into the function model. To get simultaneous equations. If I was British, I might say simultaneous. And probably ought to over the screen a little bit there. Let me check my time over here. I'm sure I'm over time. Just means that the video is going to be split into two. About a minute ago, we got to the point where it splits. So, I'd rather have thought about it a minute ago, but that's not a big deal. It's just that I can't predict where it splits. Just be ready for that. Okay, graph the data, sketch the curve, choose the points in the curve, and substitute into the function model. Get your simultaneous equations, and solve for the parameters. Substitute to get the function. That's a function model. And then getting into really sophisticated mathematical terminology, use the model to predict stuff. For example, the flow model, you got a quadratic model, you got a quadratic function. And now, when is the value of that function 48? Well, set that model equal to 48 and solve it. It's going to be a quadratic equation. Okay? If the model is if you want to know when the function takes a given y value, you set it equal to the y value and solve. Okay? If you want to know what the value is for given x or t value, you plug that in and you find out what the value is. And you got to know what the model is. Okay? And interpretation. You got to know what the model means. If it's a flow model, you got to know that y represents how deep the water is, or the position of the water surface. And you got to know that x or t is the time. If it's a projectile where you're given the height as a function of time, then you got to know what that is. So if I ask you when is the height 48, you can tell me. When's the height maximized? Well, you better be able to find the vertex of the parabolic function and maximize it and interpret all that stuff. Okay, that's a pretty good overview. I guess there's one last thing that's worth doing. Not sure I want to constrain myself to do it on the room I have here. I think I can get this board up there without having it fall off the ledge. Okay, just kind of a closing model. I'm not sure I've done this in the course. And you might be happier if I didn't do it, in which case I'd have to give you a little direction on the final, but I'm going to throw it in here. Okay? Let's just say, I think we've done this. Yeah, we've done exponential models. Okay, well, I'm just going to close it out anyway. It's kind of a big deal that if you got 2 points in a graph, you get an exponential or power function model. Okay, so let's just say this point is 3, 1. So I'm going to do this very quickly. We've still got 3 minutes. There's plenty of time. And this point is, let's say, 10, 5. Okay? Maybe this is a power function, maybe it's an exponential function. One way or another, graph might look something like this. And that's more of an exponential function probably than a power function. You can't do a quadratic model. You could also do a linear model, of course. A linear model would be a straight line. Okay, so linear model could be mx plus b or ax plus by equals c. And my linear model didn't go through this point very well, but it should have. You would get 1 equals 3m plus b. You would get 5 equals 10m plus b. And that's very easy to solve for m and b linear model. And you get simultaneous linear equations. So you just subtract one from the other, b gets eliminated, solve for m, then plug that back into one of the equations and solve for b. Or you could get ax equals b, which would be 3a, ax not equals b, but 3a plus y equals model be ax plus by equals 1, that's standard model. So that would equal 1. 10a plus 5y equals 1. Then you add multiples and so forth. Again, it's linear. Okay, well, we're out of time, but I'm going to write it down anyway. Exponential model. I'll use y equals a times b to the x. There are other exponential models you could get. You're going to get two equations again. You're going to get 5 equals a times b to the 5th, and 1 equals a times b cubed. So you could solve one equation for a and then plug that into the other. Or you could divide equations. So I'm just going to say solve one for a, substitute in the other, etc. And you don't have to use logs or exponentials or anything to do that. You just get simple algebraic equations. Okay? For power function, y equals a times x to the p. So you would get 5 equals a times x to the 5th, and 1 equals a times x to the 3rd. And that's wrong. Y equals a times, okay, let's see, 5 is going to be 10 to the p, and this will be 5 equals a times 3 to the p. That 10 looks like an absolute value sign in front of a 0. But then And I didn't give you the alternative here. Alternative. You can divide one of the equations either up here or down here by the other, eliminating A, solve for B. So I'll just say here, etc. You're going to need to use logarithms because one of your unknowns is in the exponent. And we've done examples of these at least once, maybe twice, so you should be in good shape there. Okay, well that's it. For a quick review, overview, giving you some idea of my thinking about the course, and you'll see how that works out. And at least one example, and I'll give you at least one example of a final exam. Maybe a wider variety of questions, but don't expect the exam to look exactly like the examples I give you. And do expect that most of the tests will be stuff that you've seen and done in the course, and applications of the things you've seen and done in the My Open Math assignments, within the context of stuff I just talked about. Okay? If you have questions, ask them. I'll be able to respond pretty well the rest of today, tomorrow, and Saturday. Sunday and Monday are iffy. Okay? Going to have to be traveling out of town, and I'll be pretty well tied up, at least the early part of the day on Monday. And probably, you know, a little sleep deprived for the rest of the day, but that usually doesn't bother me on the first day. After that, next week, I'm going to be out of town for at least 3 days next week, and maybe for all 5 days. Do have internet, don't have Blackboard available, but I can respond to emails. I expect I'll be able to respond to emails. Going to schedule the exam for the exam period, and I'm not sure, I think I said this already, but I'm saying the same thing in a lot of different classes. I think I said it at the beginning of the hour, but if you need to do it at a different time, let me know in advance what time that is, and we can get the exam to you. It will probably be emailed either at the beginning of the exam period or at a time that you prefer. The exam period runs through Friday of next week. I don't need the exams until Friday. There's even a possibility I could accept them through Monday, but that's not certain yet. I haven't yet checked when I need to have final grades in. I have only 2 of you here, so if I get it, you know, if I get the exams even a couple of hours before the grades are due, assuming that my time is free at that time, be able to deal with it. So don't count on being able to go past Friday, but if I find that that's possible, I will let you know. Okay. So you'll get an email detailing all that, and I think I might be repeating myself. Any questions at this point? Well, while you're thinking, I'll tell you I'm well impressed with the work I've seen from this group, and I'm going to miss working with you. But encourage you to go on with quite a bit of more math. You obviously have some ability, and it might or might not help depending on your field, but it isn't going to hurt. And the more math you do, the better you're going to be at thinking through anything. So please consider taking a lot more math. Not sure I'll see you in any of my future courses. You need at least a year of math before you get into the courses, a year of calculus before you get into the courses that I usually teach. Although my schedule for next year isn't established yet. Okay. If no questions, that'll be it. And I look forward to seeing your work on the exams. Email me at any time. I'll respond as quickly as I can.